There is a chair here if you want. Here. Oh, there's there.
Okay, Professor, we're ready to begin.
Thank you, dear. Good evening, everybody. And again, I thank you so very much for being patient with me and attending this review session. This is review session number 2, and I promise you this is the last one. Thursday. Sorry, Friday. I'm not used to writing Friday. Friday, January what? 24. Thank you. Okay. Now, let's continue our review of the QoS models. I want you, after today's session, I want you to feel almost comfortable with the material. And I will give you also some numerical examples today so that you can see a little bit how you apply it, QoS models. Now, we studied the last mod. What was the number? Do you remember the number? No, the number of the model. 4? Okay, 4. We studied this model, MMCC, which we refer to it as what? The loss model, or sometimes they call it what? The Erlang B model. And the most important equation that we derived was what? Was P of N. Was P of N, which is the probability that there are, remember this one here, there is no what? There is no waiting. There is no place to wait. Are you following? Now, this is similar, listen to me, if you make a call, you want to make a call, and you get a recording telling you what? All circuits are busy. Please try again. Do they tell you, please wait? They tell you what? Please try again. All circuits are busy, which means what? All the servers are busy. Clear? Okay. So we found that the probability that we do have n packets in the system was what? Was lambda over mu to the what? To the n over what? N factorial divided by what? Divided by the summation of what? Lambda over mu to the what? K over what? K factorial, and the K goes from where to where? 0 to C. And this is for n equal to what? 0, 1, all the way to what? All the way to C. Then we defined the probability of a blocking. This is the probability of a blocking. This is equal to what? Equal to the probability of what? N equal to what? C. When n equal to C, which means what? There are n C packets in the system, which means what? All the servers are what? Are busy. Then the system will become what? Will become blocking. More packets coming will not enter. And this was equal to what? Equal to lambda over mu to the what? C over what? C factorial divided by what? The summation K equal to 0 to C of what? Lambda over mu to the K over what? K factorial. Clear? Okay. And then this quickly from last time, then we defined the actual arrival rate. This is the actual arrival rate. It was equal to what? Was equal to lambda times what? 1 minus the probability of what? Blocking. 1 minus the probability of blocking. Why? Because those packets that are not going to enter the system will have no effect on what? Will have no effect on the what? On the occupancy of the queue inside the occupancy of the queue inside the system. Clear? They are not going to enter the system. Now, then we made a mistake at the end. Please make it corrected at the end of the last session, which is what? The server utilization. This is the mistake we made. And the gentleman corrected me at the end of the class after you left. So please correct this. What was it? It was lambda A over what? C mu. I think I just wrote mu. Yeah, put a C because we have how many servers? We have C servers. They are all going to what? to handle the traffic. So on the average, each one of them will get what you need to divide by C. Clear? Okay, so please don't make, by the way, I already, when I gave them the charts to post, I already made the correction, but you need also to make it in your, so this one is what? Land 1 minus the property of blocking divided by what? C mu. Clear? That is called the server utilization in a blocking system. And again, as I told you last time, this will be one of the parts of the mini project, or I call it mini project. Actually, it's an extra credit that will be I will be assigning this week. Clear? Okay. Now, let's look now at before I give you more examples. Numerical examples. Let me give you one more model, and this one is actually more important to us, which is what? MMC. MMC. There is a space here if you want. Sir, I told you to remove this. We don't have enough chairs. Are all the chairs occupied now? Oh, there is one here. Okay. Put it on the floor. What is it? It's made of what? Diamond? It's just a tote bag. Okay. So, MMC. Explain it to me. Explain it to me. MMC. MMC means what? The arrival is what? Boson. The service is what? Exponential. How many servers do we have? C servers. However, there is no limit on what? There is no limit on the size of the queue, which means this one is a what? A delay system, as opposed to what? As opposed to the loss system, which means what? It means this one is what? Is in the PSTN for the telephone network, whereas this one is the what? Is in the internet with data, where the data will be what? Or the packets will be what? Buffered until what? Until the server becomes available. Clear? Okay. Let's set it up. Okay. Now, so we have, by the way, again, the missing parameters means what? The size is what? Infinity. The population is what? Infinity. And the priority, the queuing discipline is first come, first serve. But notice, by the way, when the when the discipline is not first come, first serve, we will discuss it in regular classes. Because I don't assume that you have taken it in what? In 503. It's not a material of 503. Clear? So all of this is what? First come, first serve. Let's set it up. Let n be the what? The number of packets in system. Again, both waiting and being what? Being served. Both waiting and being served. Clear? How many states do we have? How many states do we have? Infinite number of states. Clear? Infinite number of states. Let's catch a couple of them. 0, 1, 2, C plus 1, ... Did you get it? Okay. Now you might say, why did you write C plus 1? I'll explain to you in just a second. Are you following me so far? Okay. Let's start with here. The system is what? Idle. Suddenly it transit to what? 1. What happened? One packet came. Clear? One packet came. Under what process? Under an arrival process. So this one is what? Landed. This one is what? Mu. Clear? Okay. What? Another packet came. Clear? Are the second packet, by the way, is he waiting or is he being served? Is he being served? Because we have C servers. Clear? Okay. So what do I have? This is what? Landed. Let's see. Be careful. What is this? To mu. And I think I explained this one to you in the morning. Do you remember it? Okay. When you do have the minimum, in other words, when we say to mu means what? Which server finished first? The minimum service time. Clear? To mu. Okay. Next one will be what? Lande. What is this? 3 mu. Now, explain this one to me. What is this? Lande. What is this? C mu. Not C plus 1 mu. Are you following or not? It is C mu. We only have what? C servers. So when we say C plus 1, what does it mean? C packets are being what? Served. And 1 is what? Waiting. Clear? Okay. Similarly, this one is what? Lande. And this one is what? C mu. And this one will continue on and on. Clear so far? Clear so far? Okay. By the way, the first most important part in modeling of queues is to be able to sketch what? The Markov chain, the transitional Markov chain. Clear? Okay. So, can we write the steady state? Can we write the steady state? How we can write the steady state equilibrium equations? And by the way, right now we don't know if there's a condition on the lambda and the mu, like we saw in the case of what? MM1. In the MM1, was there a condition for stability? What was the condition? Lambda has to be less than mu. In here we are not sure yet, because we do have what? Multiple servers. Clear? So let's wait and see how it develops analytically. Can I take this here edge? So what do I have? Lambda P0 equal to what? Mu P1. Which means what? P1 equal to what? Lambda over mu times what? P0. Clear? Okay, now question before I proceed. Question. In here, do I need to divide the regions into the equations into two regions? Why? Because in here, if you like in here, all of these is based on what? Service is what? C mu. But once you start here, all of them will be what? Constant, C mu, so the equation will change. Did you get my point or not? So keep that in mind. Okay, the next one is what? Help me. Lambda P1 equal to what? 2 mu P2, which means what? P2 equal to what? Lambda over what? 2 mu? No, I messed up. I'm sorry. 1/2 times what? Lambda over mu square times what? P0. Clear? Okay. And then take this one. Don't go to this one. Just take this one. What is it? Can we generalize it? In other words, can you tell me what is Pn equal to for what? For n equal to what? 0, 1, all the way to what? C. Clear? Can you tell me what is it? Do you see a pattern? What is it? What is the next one? Let's look at the next one and then we generate the pattern. What is the next one? Lambda P2 equal to what? 3 mu P3. Which means what is P3? P3 is what? 1 over 3 times what? 1 over 2 times what? Lambda over mu cube times what? P0. Clear? Do you see a pattern? So what is it? Pn equal to what? Lambda over mu to the what? N over what? N factorial times what? P0. Clear? Clear? Do we need another region? We need another region. Why? Because this one is not the same as this one. Clear? Okay. Now, so let's start in here. By the way, what do I want you to think? I want you to think that this is a new chain with this one being what? P0. But instead of writing it P0, it's now what? PC. In other words, as if this one does not exist. Base it on this one. Did you get my point? Which means what? Listen to me. What am I going to write? Continue. Lambda PC equal to what? C mu times what? PC plus 1. Which means what? PC plus 1 equal to what? Lambda over what? C mu times what? PC. Clear? Give me the next one. Just the next one and then that's it. Next one. Lambda P C plus 1 equal to what? C mu, same thing, C mu. Everybody see that it's the same thing? C mu times what? P C plus 2. Which means what? P C plus 2 equal to what? Lambda. Let's see if you can help me. It's lambda over C mu times this. So it's what? Lambda over C mu square times what? PC. Did you get it? Did you get it? Okay. Can we generalize it now? Let's see if you can generalize it for me. Do we do another one or do you see it? Or do I need to write another one? Okay, good. So let's generalize it. What is P? What is, help me. What is Pn for n? What? C plus 1 all over the place. Notice, by the way, the expression in here for n equal to what? C should be the same as what? The expression in here when n equal to what? C. Did you understand what I just said or not? Keep that in mind. Okay, where is it? Do you see a pattern here? Now notice, I want now to take it back all the way to what? to P sub 0. So what will it be? Let's see if you can help me. Lambda over what? C mu. Lambda over C mu. Still waiting. Raised to the power what? Say that again. N minus C. Did you answer where this N minus C came from? Or you lost me? Okay. Denominator. Tell me, what do I put in the denominator? Okay, what do I have here? C mu square. But remember, this is beginning from where? From PC. So what do I have? You lost me? C mu to the what? I messed up? Oh, there's already in here. So what is this? C to the what? Okay, one more time. I messed it up. One more time. Pn. Let's write it together. Better. Let's write it together. So what is the first one? Lambda over mu to the what? N times what? P naught over what? N factorial. This is what? For n equal to 0, 1, all the way to what? C. Now, what do I have here? Tell me. I have lambda over what? C mu to the what? N minus C. Is this correct? Yes. Okay, so it's what? Lambda over what? C mu to the what? N minus C times what? C factorial. I messed up. See, this one is what? It's PC. So it's what? See, it times what? Times P0. No, but this is not C factorial. Say that? No. Times what? No, I messed up. One more time. One more time. What is PC? What is PC equal to? PC equal to what? Lambda over mu to the what? C over what? C factorial times what? P0. Agree? So in here, instead of PC, I'm going to write what? Lambda over mu C so this one should be what? Why we are stuck in here? One more time. Lambda over what? C to the what? Lambda, one more time. One more time. Lambda, oh, this one here is what? PC plus 1, right? So it's what? Lambda over, so when n is equal to C plus 1, what is this? This is lambda over C mu times what? PC, which is what? P0. Oh, so there is this term. Okay. Don't get mad at me. Don't get mad at me. So what is it? Lambda over mu. Here? Here. Okay, times lambda over mu. Times what? P0. Yeah. Okay. So let's just to make sure, check it. Let's just to make sure. This is for what? N equal to what? C plus 1, so on and so forth. Let's just make sure that it is correct. At n equal to C, what is this term? Huh? At n equal to C, this one is 1, so I get this. At n equal to C plus 1, what is this? This is lambda over what? C mu to the what? 1, yes? Over what? C factorial times what? Lambda over mu, C P naught, but this is what? PC. Clear? Clear? Okay, good. So now it's okay. So lambda over C mu to the n minus C times what? There is a bracket here. There's a bracket. Lambda over mu C P naught over C factorial. Okay. What do I need to find from these equations? I need to find P sub 0. Yes? So what do I say? I say summation of P sub n is equal to what? 1, n equal to what? 0 to what? Infinity, which means what? P0. What is P0 equal to? Let's see if you can tell. I'm going to write it this way just for simplicity. Minus 1, which means what? It's 1 over this. Clear? What is the first term? Now, since these both have C in it, I'm going to take this one from 0 to C minus 1, and I will include C in this term. Clear? You cannot include it in both terms. You need to include it in one term. So I will include it here. So what do I have here? Summation n equal to what? 0 to what? C minus 1 times what? Lambda over mu to the n over what? N factorial. Agree? Agree? Plus, what is this? Summation n equal to what? C to infinity lambda over C mu to the what? N minus C, yes? Divided by what? Divided by C factorial? I messed up? Times what? Lambda over mu to the C. You agree? Okay. Can I get this one outside? This one. Can I get it outside? Okay, so what do I get? P sub 0. Okay, a question first one. Do I have a problem with this summation? Why? Because this summation is what? Is a finite summation. Do I have a problem with this summation? Yes, I do. Because this one is a what? Is an infinite summation. Clear? Okay. Help me. How can I write this? How can I write this? Summation n equal to 0 to C minus 1 of what? Lambda over mu to the n over what? N factorial. Now, what can I do here? Let's see if you can tell. What do I have here? See, I need to change the variable in here such that it begins from what? From 0 to infinity. Which means what? I want to say let m equal to what? N minus C. Clear? Okay. So n minus C in here is m, but what do I have in here? Can I get this one outside? This one. Can I get it outside the summation? Because it does not have n in. So what is it? Lambda over mu to the what? C over what? C factorial times the summation. I'm going to make simple change of variable. M equal to what? 0 to infinity of what? Lambda over C mu to the what? M. The whole thing raised to the power what? Minus 1. Did you answer? Where did I just said what? Let n minus C equal to what? M. So when n is equal to C, m is equal to what? 0. When n is equal to infinity, m also equal to infinity. Clear? Clear? Okay. Now, one more time. Do we have a problem with this? We don't have a problem with this. Now, if this diverge, listen to me. If this diverge, what is P sub 0? Remember, P sub 0 is what? Raised to the power what? Minus 1. So if this diverge, which means what? This is infinity, P sub 0 will be equal to what? 0. Which means what? It means the servers, so the system will never be what? Will never be empty. Are you following? Will never be empty. Did you get this or not? Okay. So for this to diverge, for this to converge, for the second series, to converge, lambda over C mu has to be what? Less than 1. Clear? Lambda over C mu has to be what? Less than 1. Now we say what? Define rho, which is the what? The server utilization. The server utilization equal to what? Lambda over what? C mu. Clear? Lambda over C mu. In the MM1, what was the server utilization? Lambda over mu, because we had a what? A single server. And here, if you plug in C equal to 1, you get what? The same definition. Clear? You get the same definition. Clear? Okay. So I'm going to denote it by rho. So what do I have? I have P sub 0 equal to what? Summation n equal to 0 to C minus 1 of what? lambda over mu to the n over n factorial plus what? Okay, what is this? What is this? This is 1, this is rho to the m. So the summation will converge to what? 1 over what? 1 minus rho. So what do I have? Lambda over mu to the what? C over what? C factorial times what? 1 minus rho. And the whole thing to the what? Minus 1. This equation 1. Equation 1. No, this equation. This equation 2. Clear? Clear? Yeah. By the way, this one we will, in the example, this one cannot be simplified anymore. This is the best we could do. And then we need to what? We need to plug in the values that will be given in the problem, as I will show in just a second. When you get p sub 0, you are going to plug it in what? You are going to plug it in here and then here. Clear? Clear? Okay. Now let's see if you can help me get some of the important parameters in our model. Okay. We start first of all with the following. What is the probability that W? What is W stands for? Waiting time. What is the probability that W is greater than 0? Now, first of all, let me ask a question before even we proceed. What kind of a random variable is W? Mixed. Why is it mixed? Is it possible that you don't wait? When? By the way, what I'm calculating right now is what is the probability that you have to wait? Clear? What is the probability that you will not wait? 1 minus this guy. Do you understand that or not? Why? You either wait or what? You don't wait. Clear? Give it to me. In terms of what? What do I see? This is a random variable W that I have no idea yet how it is distributed. You need to change this. Is this an event? Remember, from probability, it's first thing you started is what? Definition of an event. Is this an event? Define this event in terms of who? An event that you already know the PMF of, which is what? N, capital N. Clear? When will W be greater than 0? When, ask yourself, when is an incoming packet will wait? I'm hearing too many answers, and I got they interfered with each other, and I did not get it. Is the probability that what? N greater than or equal to what? C. Not equal to C. Not equal to C. Greater than or equal to C. You are losing me. You lost me. I can see the faces. If you are here in this state, what is happening? All the servers are what? Busy, and there is one what? Waiting. Yes? How about this one? The next one. All the servers are busy, and what? Two waiting. Are you following? So you are going to wait all of these from here to there. Clear? Clear? How about if you are in C? Are you going to wait an arriving packet? An arriving packet to the what? To the router. He sees C packets in the system. Will he have to wait? He has to wait. So it's what? The probability N greater than or equal to C. Clear? Help me. Help me. What is it? By the way, this is the probability. N is a what? Discrete random variable. Yes? So what is it? Summation from where to where? From N equal to what? C to infinity of what? Only this equation. Do you agree? I don't worry about this equation. So what is it? Lambda over what? C mu. I want to write this one as an rho. I'm going to write it in a minute. N minus C divided by what? C factorial times what? Lambda over mu to the C times what? P0. Clear? No response. Clear? Okay, and that's equal to. Now, I want you to see this. What is this? What is this equal to? PC. Do you agree with me or not? So I'm going to write it so that I don't need to repeat all of this. It's what? PC times the what? Summation n equal to C to infinity, rho to the what? N minus C. Do you agree? Sorry, this is like this, the whole thing. Do you agree? Agree? Rho to the N minus C, which is, can I simple change of variable here? N minus C equal to M. So what do I get? PC over what? 1 minus rho. Are you following me or not? One more time. This is not rho. Are you getting confused? What is this? This is the probability that what? That there are, this is the probability that what? That there are C packets in the what? In the system. Clear? Clear? Notice, by the way, I did not say that this is the probability that all servers are what? Busy. It's not the same thing. Is it possible that all servers are busy, but there are still some packets waiting? Yes or no? So this PC means what? The probability that there are what? C packets in the system, all of them being what? Served, which means how many waiting? 0 waiting. Clear? Okay, good. Now, so this equation, I'm going to write it again, this equation, which is what? Probability that W is greater than or equal to what? 0. Not equal, I'm sorry, I said equal to 0. Probability of W greater than 0, which means what? The probability that an arriving packet has to what? Wait is what? Equal to P sub C divided by what? 1 minus rho. Clear? This equation is called the Erlang, again, after the mathematician came with it, Erlang C formula. Say that again? Very nice. No Erlang A, just B and C. Clear? Clear? Okay, good. Now, let's see if you can help me. What is the probability? What is the probability that W is equal to 0? What is the probability that an arriving packet will not wait? Is what? Is of course 1 minus PC over what? 1 minus rho. Do we agree? Okay, good. So this is equation 3, equation 4. Okay, let's see if you can help me with this now. What is the expected value of NW? What is the expected value of NW? In words, what is it? On the average, how many packets are what? Waiting. Still waiting. Still waiting. Still waiting. I need an answer from you. Okay, first of all, is this a discrete random variable? That's expectation, which means right away we know it's a what? Summation. So it's what? Summation. Now listen to me. If the number of packets in the system was C plus 1, how many of them are waiting? 1. If the number of packets in the system is C, how many packets are waiting? 0. One more example. If the number of packets in the system is C plus 2, how many packets are waiting? 2. Look what I'm going to write. N minus C, yes, times what? From where to where? Did you get it or you lost me? By the way, this one, when I say Pn equal to n, which one am I going to use? I'm only going to use this one. Did you get my point or not? Yes or no? Did you answer where this n minus c came from? Start. N equal to c. Where is this? 0. Why? Because there are what? 0 waiting. n equal to c plus 1. How many waiting? 1. Times the probability what? That it is n equal to c plus 1. Yes or no? Clear? Okay, good. So that's equal to summation n equal to c to infinity n minus c times what? Let's see if you can help me. Lambda over cu is what? Lambda over cu is what? Is rho. Yes? So it's what? Rho to the n minus c. Now, what is this? What is this? This thing here. This thing here is PC. You agree with me or not? So this one times what? Times PC. Agree? Can I get the PC outside? Why not? A PC, as a word, does not have any n in it. Did you lose me? Did you understand where this came from? Okay, good. And that's equal to P sub C, summation. Can I change the summation into another dummy? So what do I say? M equal to what? 0 to infinity of what? M rho to the what? M. Clear? Did we see this trick last time? Okay, so what do I do? Equal to what? P C times what? Rho times what? Summation. M equal to 0 to infinity. D by d rho to the M. Did you get it? One more time. What is d rho to the M? Is what? M rho to the M minus 1. I don't have the rho minus 1, so I multiply by what? Rho. Agree? Can I interchange the order of summation and integration? Oops. Can I interchange the order of summation and differentiation? Why? Because summation is with respect to what? M. Differentiation with respect to what? Rho. So what do I get? PC times what? Rho times what? D by d rho of what? Square. No, just like this. When you take the derivative, it becomes square. Clear? Clear? Okay. And that's equal to what? PC over what? 1 minus rho times what? Rho divided by what? 1 minus rho. Did you get where this came from? Yes or no? What is the derivative of 1 over 1 minus rho? 1 over 1 minus rho square. Yes? And then I split the 1 minus rho square, one of them with this, or the other one with this, just for one purpose. What is the purpose? The purpose is that you can see, what is the purpose? The purpose is that you can see that this one is actually what? The Erlang C formula. Clear? Clear? Okay, this is equation what? Equation 5. Now, once you found E of NW, by the way, what is the effective, what is the actual arrival rate in this case? Is it still lambda? In this case. Why? None of the packets will be what? Blocked. This is not a blocking system. Clear? None of the packets will be blocked. Can we use littles here? So what do I have? I have E of what? W. Yes? Equal to what? E of NW over what? Lambda. This will give me the what? E of W. Yes or no? It's on equation 1. Equation 6. Clear? Okay. What else do I have? I have E of T is equal to what? E of W. You lost me? Plus what? Do I have this? Do I have this? Do I have this? Why not? E of, the server is what? Did I mention? What does this M stands for? Exponential with rate of what? Mu. Yes? So, this one is equal to what? 1 over mu This one, equation what? Equation 6. I get this one. That's equation 7. Yes or no? And one more. One more. What is the one that's missing? E of what? N. Which is what? What is E of N? E of N is what? Is the average number of packets in the what? In the system. Which is what? E of what? What is it? E of NW plus what? What is E of NS? What is E? No. What is it equal to? That's equal to what? Lambda times what? E of what? S. Clear? Clear? Let me ask you a question. Can you find E of N in a different way? Huh? Besides that, okay. Lambda, yeah, you got me here. Lambda E of T also. Same thing. But can you find a different way? You got this. Yes? Where is E of N? E of N is actually what? E of N is the what? You agree? But in this case, you need to sum from where to where? 0 to infinity, which means you need to split this summation into what? Into two parts. One you use this, the other one you use the other one. Clear? Clear? Okay. Now, I need also to show you, see, right now we found E of, what did we find? We found, for example, E of W. Yes? But do we know how W is distributed? We don't know how W is distributed. You follow me or not? I need to show you that. But I need first of all to show you a numerical example based on this one here. Just an example so that you understand what I'm talking about. Let's take a couple of examples here. Examples. I will come back to continue. Did you follow me so far? Okay, examples. Number 1. It is desired to compare.
The time is 21 o'clock.
To compare the expected value. What is this E of T? ET means what? It's not ET, the extraterrestrial. ET stands for what? Expected value of what? Total time. Average time. ET and E of what? W for the following two Qs. Let's see if you can help me. Notice, by the way, in all of this discussion, we have been interested in only what, or we have been dealing with only what? One Q. In reality, do we have one Q or we do have multiple Qs? Remember routers. But that, I don't assume that you have taken it in 503. I need to show it to you in class. Clear? So all of the discussion in here is what? Just one Q. Now you might say, but you just said 2Q. No, these are two different Qs. Two different Qs. The first one is an MM1. I have an MM1 with a server whose service rate is what? 1. And the arrival rate, lambda, is what? 1/2. Why did I make this 1/2? Remember, it has to be less than 1. If it is more than 1, it will blow up. Clear? Okay. What is the server utilization here? Here. Server utilization is what? 1/2. When you compare two systems, two queuing systems, you need to compare what? Apples with what? Apples. Oranges with what? Oranges. You follow me or not? You cannot compare two systems in which one of them is using a powerful server and the other one is using what? A weak server. Did you get my point or not? Of course, the one that has a power server will be better. I want you to see the following. In here, we had a single server who is servicing at a rate of what? 1 packet every what? Second. I'm going to replace it with 2 servers. Each one at a rate of what? 1/2. Which means what? Each of these servers are faster or slower? Slower. The arrivals, however, is the same. Lambda is still what? 1/2. Did you get my point or not? Lambda is still 1/2, but instead of using one server at a service rate of what? 1, I'm going to use what? 2 servers, each one at a service rate of what? 1/2. Are you following? What is the server utilization here? Server utilization. How did you find it? What is C, by the way, in this case? C is 2. What is the server utilization? Lambda over what? C mu, which is what? 1/2 times what? Divide by what? 2 times what? 1/2, which is what? 1/2. Are we comparing apples with apples? We are comparing apples with apples. The server utilization is both the same. Clear? What is the question is asking you? He is asking you to compare E of T, which is what? The average total time spent in the system, and E of what? W, which is the average waiting time. Average waiting time. What does your intuition tells you before we prove it analytically? What does your intuition tells you? Intuition. Let's take first of all the waiting time. Do you think that the waiting time here, E of W, here, compared with E of W here, which one do you think will be higher? You will see that the first one will be what? Higher. Are you following me or not? Cannot hear you. Okay. What about E of T? Which one do you think will be higher? The first one or the second one? The second one will be higher. Why? Because the servers are what? Slower. Did you get my point or not? The servers are slower. You lost me? Did you lose me? I cannot see these 2 young ladies here. Did you lose me? Huh? I don't know why you are sitting behind so that you take a nap. Are you following me or not? Yes or no? Let's do it. Let's do it. So, case 1, MM1. By the way, these types of problems I will ask you in the midterm. I'm not going to ask you to do derivations and stuff like I'm doing, but I'm going to see, when I give you a problem, I will not give you the model. I will not tell you that this is what MM1 or MM2. You need to figure it out yourself. But the equations, all of these equations will be with you. The 8x11, you are going to bring the 8x11. All of this will be with you. Clear? But you need to figure out what is the model. Are you following? Now, this question is easy. I'll give you another question in just a second. Help me. Help me. What is E of T? Of course, you don't remember this equation because we did this one yesterday, not even today. It was what? 1 over mu minus what? Lambda, which is equal to what? 1 over 1 minus 1/2, and that's what? 2 seconds. Clear? Clear? Okay. And what is E of W? What is E of W? E of W is equal to what? E of T minus E of what? S, which is equal to what? 2 minus what? 1. And that's 1 second. And we are done with the MM1. Did you get it or not? Cannot hear you. MM1 is pretty straightforward. Now, for the MM2. What do I need to find first? I want you to see the equation of E of W. This E of W. E of W depends on what? E of what? And wait, it depends on what? E of NW. Agree? E of NW depends on what? P of C. Do you agree? P of C, where in the world is P of C? 1 second. P of C depends on what? P of 0. You follow me or not? So what is the first thing that I need to find? I need to find P of 0 before you do anything. Do you understand? Because all the equations are in terms of what? In terms of P0. Clear? Okay. Where is the equation of P0? This is the equation of P0. Yes? Okay. It's a question. How many terms in this summation do I have? Remember, C equal to what? 2. So how many terms in this equation do we have? 2 terms. Yes? Let's plug it. So P0, did you follow me? Okay, so P0 is equal to what? Help me. What is the first term? Now, what was the lambda? This one is for this one. What was the lambda? Lambda is what? 1/2. Yes? Mu is what? 1/2. So this is what? 1/2 over 1/2 is what? Is 1. So the first term is what? 1. And the second term is what? The second term is when C equal to what? 1. Sorry, when N is equal to what? 1. So I also have what? 1. Do you agree? Okay, 1 plus, what is this? 1, did I mess up? Lambda over mu is what? I messed up? Lambda over mu is what? 1 raised to the power what? 2. So that's 1 square. 1 divided by what? 2 factorial, which is 2. 1 minus rho, which is 1/2. I messed up? So this cancel with this? So where do I end up? How could you promote me? I forgot my one. Saved by the bell. Saved by the bell. Minus 1, which is what? 1/3. Clear? Clear? Next, what do I need to find? Yeah, I need to find PC. Where is the PC? Where is the PC? Equation for the PC is this one. PC is what? Lambda, let me write it down so that lambda over mu to the what? C over what? C factorial times what? P0. Okay, now lambda over mu is what? 1. Yes? So this one is 1. Over what? So this one is what? 1/6. Do you agree? Agree? No response. Agree? Oh, now, what else do I need to find? What is E of NW? Do I need to find something else or that's it? Okay, what is the probability that W is greater than 0? Which is the what? Which is the Erlang C? What is it? It's PC. Let me write it again. PC over what? 1 minus rho, which is what? 1/6 over what? 1 minus 1/2, which is what? 1/3. Very good. Okay. And then finally, what do I need? E of NW. This is this equation. Yes? Yes? This one is what? It's 1/3 times what? 1/2 over what? 1/2. So that's 1. And that's equal to what? 1/3. And what is E of W? E of W is what? E of NW over what? Lambda, which is what? 1/3 divided by what? 1/2 equal to what? 2/3 second. Clear? Clear? Question. Our intuition, was it correct or not? 1 second. 2/3 of a second. Clear? Yes or no? Okay. And what is E of T? E of T is what? E of W plus what? I messed up? E times E of S, which is what? What is E of W? What is E of S? Is 1 over what? Mu. But the mu is what? And so this one is what? 2. Which is what? Help me. 8/3 second. Compared to who? 2 seconds. Clear? Clear? Okay, let's take another example. Did you understand it? No response. Are you following me? Yes. Okay, next. next example. Suppose I have two companies. This is two sides of a company, sorry. This is A, this is B. And you have three lines connecting them. Three, for example, video conferencing lines. Three lines connecting them. Clear? And the traffic all from A to B, not B to A, just A to B. So it's one and one. Okay. The owner of the company has two options. The first option is first of all, the average arrival rate is, let's say, 2 calls per, let's say, per minute. Clear? 2 calls per minute. Okay. And the average service time is, let's say, 4 minutes per call. What is this? When I say average arrival rate is 2 calls per minute, it means what? This is lambda. And average service time is 4. What does it mean? Mu equal to what? 1/4. But is this correct? We need to make sure that the system is stable. What is the rho? Rho is what? Lambda over what? C mu. So what is lambda? 2. And C mu is what? Okay, let's add another line to make the math simple. Add another line. So the C is what? 4 times what? 1/4. I messed up? Too large? So what do I do this? 5? 1? 1. No, still wrong. 0.5. Is now okay? Is now okay? Okay, good. 0.5 calls per minute. Average service time is 4 minutes per call. Case 1. If all lines are busy, arriving calls, okay, new arriving calls will be delayed. And case 2, if all lines, these are all what? Private lines. Private lines. If all lines are what? Are busy, any new call will be forwarded to the PSTN. Did you understand the difference between them? The first one is what? Is that if all the lines are busy, which means what? It's occupied, somebody is making calls, yes? Any other new call coming will be what? Delayed. The other one, if all the lines are busy, the call will go through what? The public switch telephone network. Remember, these are private lines. It goes through what? Through the public network. Clear? Okay. A, find the probability that a call will wait. This is for model 1. And for model B, what portion of calls are directed to PSTN? What portion of the calls, when it says portion of calls, means what? What is the probability that the calls will be what? Will be forwarded to the PSTN. You notice the question did not give you what? The model. And that is the same in the midterm, like this. I'm not going to give you the model such that you just plug in and then that's it. Clear? Oh, tell me. What is the first model? Case 1 is what? No. MM4. This is case 1. Why? Because incoming calls that see all the servers, all the lines are what? Busy will be what? Will be delayed, will be waiting. Now you might say, but how do I know that the buffer is what? Infinite. That question will give you. It will tell you, assume that the buffer is what? Infinite. Because if the buffer is not infinite, it needs also to tell you that. Clear? Okay. Case 2 is what? MM. Did you understand how does the model change? Why is it MM44? Why? We have 4 lines, yes? The maximum number of calls has to be what? 4. And any other call will be directed to what? To the PSTN. Did you get this or not? Yes or no? That I will not give you in the problem. You need to figure it out. And you will see it also in some homework problems and something like that. Clear? You need to figure out from the model. Clear? Okay. Now help me. By the way, I'm not going to solve this. I will let you know. Do it at home. It's just an equation. But just tell me what is the question he's asking. In here, MM4, he is asking for what? What is the probability that W is what? Greater than 0. Which is what? Which is the Erlang C formula. Now remember, to find the Erlang C formula, the first thing that you need to find is what? P0. Did you get my point on that? You need to find P0. Clear? By the way, I'm not going to solve it for you. You can do it at home. Clear? Oh, what is this one is asking? What is the probability? Sorry, what proportion? Not portion. What proportion? Proportion. What proportion of the calls are directed to the PSTN? What is the question is asking? And that is asking for, very good. It's asking for what? The blocking probability of what? Of blocking. Which is the Erlang what? Which is the Erlang B formula. Whereas this one is the what? Is the Erlang C formula. Clear? Can you do this at home? The rest of the problem is just a plug in. Equations you have. But did you get it? Okay. Now let's get back to the model. I'll give you some more examples in just a second. Let's get back to the model. Notes, by the way. These are the two that I will give you. This is the B and the C. The MMC and the MMCC. I will give it to you as the mini project. By the way, if you want to use, how many of you feel comfortable with MATLAB? Doing this with MATLAB. If you do it in MATLAB, you need to come to my office. I don't have MATLAB running in my machine. So you need to come to my office and demonstrate it for me. Did you get my point? No response. Did you get my point? It's killing you to come to my office. Not too many people showing in my office. I'm lonely. You know today? From 9 o'clock to what? 5 o'clock. Just sitting in the office. I'm so hungry right now. I cannot eat because if I eat, I go to sleep. Clear? Clear? However, I really would like you to learn how to do the Excel thing, the embedded. And I will send you the tutorial. You read it, straightforward. It looks much nicer than MATLAB. Are you following me on that? Okay. Now, let's get back to the problem. This now the hard part. Let's see if you can help me with the hard part. We are still in the same model. Back to the what? What is the distribution of the waiting time? Did we calculate E of W? E of W is what? Is the average waiting time. From the averages, can you find the distribution? Of course not. But from the distribution, can you find the averages? Okay. I want you to find the distribution of the waiting time and the what? The total time. I will only show you the first one. I will let you do the second one at home. Clear? Clear? Okay. Now, first of all, answer me the following question. What do you think this one is? A continuous or discrete? This one, total time. Somebody said discrete. Who said discrete? This one is a what? It's a continuous random variable. You agree? Agree or not? Mixed type random variable. Why? Is it a possibility that the waiting time is equal to 0? We already calculated. Yes? Cannot hear you. What if the waiting time is not 0? How would I get? How long will a packet comes? The waiting time for an arriving packet will depend on what? How many packets are there in the what? In the system. Did you get this or not? No response. Did you get this or not? Given that, now keep in mind, let me ask you a question. If the number of packets in the system is less than C, will there be waiting? There won't be waiting. So what I'm trying to say is that given that N is equal to what? N, where N is what? Where N is greater than or equal to what? C. When I tell you given N is equal to N, yes? What does it mean? When I tell you given, is it a random variable or no longer a random variable? No longer a random variable. I'm giving you the value of N. Yes? I'm going to find the conditional distribution, but then I need to average it over what? All possible values of N, such that N is greater than or equal to what? C. Clear? By the way, this is similar to this in MM1. Remember last time? Yes or no? But this one is a little bit trickier. Let's see if you can help me. Assume there are N packets in the system. Remember, N is greater than or equal to C. Yes? An arriving packet came. How long he has to wait before he get served? Before he started service. Remember, we are only interested in the what? In the waiting time. We are only interested in the waiting time. How long will the packet, how many packets are there in the system? N packets in the system. Yes? How long will he what? Will he wait? Now let's understand it. Out of these N, C are in what? In service. Because we have how many servers? C servers. So out of these N, we have what? C packets in service. And what? N minus C packets, what? Waiting. Clear? Yes? Okay. Now, I need you to understand one thing here. How long will be he waiting? How long will that packet be waiting until he starts service? He needs to wait until what? All of these packets are what? Served. Yes? Plus what? 1. Why? What is that 1? Huh? No, you are losing me here. We are calculating what distribution of what? The waiting time. Here the waiting time. We are talking about the waiting time. The waiting time is what? How long is he going to wait? Clear? When he entered the system, all the servers were what? Busy. One of them needs to what? Finish service. One of who? One of the servers. Yes? Now remember, the service is what? Exponential, which was what? Memoryless. Yes or no? So he need one service time for what? for the one of the packets in the server to what? Exit. Yes? And then he need what? N minus C to also what? Exit the what? The queue. Yes or no? So that he, the next will be him to be served. Did you lose me? You lost me. The waiting time. I will show you how you lost me in just a second. I will show you. The waiting time is, remember, is this the waiting time or is it the conditional waiting time? Conditioned on the fact that n is equal to what? N. The waiting time is the sum of n minus c plus what? 1 independent and exponentially distributed random variables with parameter still waiting. CMU. You lost me. You lost me. Not mu, CMU. Why? Why? We have C servers. The time between completions of the service is what? Is 1 over what? 1 over CMU, the average is not 1 over mu. 1 over mu is we do have a what? A single server. We have here multiple servers. Clear? There is no question in my mind. You are struggling. Okay. Concentrate one by one. One by one. Let's take them one by one. How many servers are busy? All of them. Yes? Okay. How many packets in the queue? N minus C. Agree? Now, when will one of the packets that is ahead of the queue, when will he start service? When the minimum of what? The minimum service time happens. Yes? What is the average? 1 over what? CMU. Do we agree on this? Now, that packet exited. The packet that was head of the line entered service. How many servers are busy? C. Now, the packet that just arrived just entered the queue. Did you get this or not? Sorry, I mean, it's inside the queue, but he what? Advanced by what? 1 unit. Yes or no? Now, how many packets are there right now in the server? C of them. Yes? When will the next one exit? The one with the what? With the one with the minimum service. Does it have to be the same server? It could be another server. Yes or no? Do I need to continue or did you get it? Yeah, every one of them will, when they exit, is what? Is the minimum of what? The minimum of the what? Of the service time of each one of these individual servers. Clear? Clear? The question. What do you get? What type of distribution you get when you add independent, exponentially distributed random variables? You get a gamma function. Give it to me. How do I write it? Give it to me. Look how I'm going to write it. F of what? W of what? T given N equal to what? N. And this N, by the way, is what? Greater than or equal to what? C. Keep that in mind. Clear? Give it. What is, why is this? I don't need this. Give it to me. It's gamma. You remember the gamma? It's what? C mu e to the minus C mu t, yes, times what? C mu t to the what? N minus C over what? N minus C factorial. before you write this, aside. If I have y equal to what? x1 plus x2 plus xn. All of them are what? Exponential, independent, with parameter mu. Let's make simple. Yes? What will be this one? It will be what? Mu e to the minus what? Mu t times what? Mu t to the what? N minus 1 over what? Factorial. Agree? How many terms were there in the denominator? N minus 1 term. How many terms do we have here? N minus c plus 1 in the denominator? 1 less, which is what? N minus c. Now in here, what is it? Mu t, because the parameter was what? Mu. In here, the parameter is what? C. Clear? Clear? Okay, good. Now, what is this? Inverse. What is this? That's the conditional distribution, the conditional CDF. The conditional CDF of what? Of W, given that n is equal to what? N. And the n is what? Keep in mind, n is what? Greater than or equal to C. Y is that one more time. Because if n is less than C, what will happen? W equal to what? 0. There is no weighting. Clear? Okay. Well, give it to me. How do you get the CDF from the PDF? To what? T. Of what? C mu e to the minus C mu x, that's just a dummy, times what? C mu x to the n minus C over what? N minus C factorial dx. Clear? Clear? Okay. Now, but what do I want? I want this. W of what? Of t. Is this conditional? It's not conditional. What is this, first of all, by definition? Is the probability that W is less than or equal to what? T. Do you agree? That's by definition. Now, could W be equal to 0? W could be equal to 0, which means what? It means that I will have a jump at t equal to what? 0. What is that? That's f. So it's equal to the probability of what? W equal to 0, yes, plus. Now what do I need to do to this? What do I need to do to this? I need to average it over all possible values of what? N. But remember, N is what? Greater than or equal to 0. Oops. Greater than or equal to C. Clear? No response. Clear? Okay, good. Now, is N a discrete random variable? So what do I have? Summation N equal to what? C to what? Infinity. Yes or no? F W T given N equal to N, which is this term. Yes? Times what? What do I plug here? What I plug here is this one. Only this one, not this one. Did you get my point or not? Only this one. Plug this, here this one, plug it here. Clear? And then, I'm not going to continue with this. You do it at home. And then what, by the way, just like we did last time, you interchange the what? The order of summation and integration. By the way, what is this? Tell me, what is this? This is what? 1 minus the probability that W is what? Greater than 0. And what is this? Just this one. That's the airline C formula. Did you get it? You need to add. By the way, when you sketch it, what is this term? This term is a jump. In other words, this is what you have. After you simplify it, I will let you simplify. You have a jump of what value? P of W equal to 0, and then what? Something like this. Did you get it or not? By the way, why is this one going to 1? That's a CDF. CDF is a probability. The maximum value of the CDF is equal to 1. Clear? Exponential or not exponential? It's not exponential. Are you following? Not exponential. Clear? Did you understand the idea? I will let you do it at home. Continue it at home. But did you get the idea? Okay. Now, let's move on to another model. Don't make noises. You have the whole weekend to enjoy. Let's see a different model now. Let's see if you can follow this. What number? What number? 6. M. Notice, by the way, how come you did not say, how come you are stuck with MM? The MG, the general distribution, I don't assume that you studied. Did you study it in 503? But I cannot assume that you went into detail in it. So that I will leave it to the class, regular class. Clear? Along with the priority queuing. But this one, look at this one and tell me what am I doing here. What is, did you study this? In 503? I'm not sure. I don't think so. But in any case, what is this? Explain to me in words. What is it? What is this KK? First of all, what is this one? One server. How big is the population? How big is the population? K. I only have what? K users. Are you following or not? K users. I want you to think about it as follows. We do have a single server that only accept requests from how many clients? K clients. K clients have the right to what? Access the server. Yes? The server will what? Reply to them. The server then what? Sit there passively, 450, until what? Until another client prepares some what? Request to send it to the what? Server. Yes or no? Is it possible that multiple clients send requests? What will happen? What will happen is that they get what? Queued, yes? But the maximum number of what? The maximum number of client, or the maximum of requests has to be what? Has to be K, which means what? If all of them send requests, the outside world, no, there are no more what? Clients, which means all of them are inside the queuing system. One of them being what? Served. The others are what? Waiting. Did you get it? Let's sketch it so that you understand what I'm saying. By the way, this one, when they invented this, it was before web servers and websites. But then they applied it to web server website. At the beginning, they called it the what? The machine repair shop. The machine repair shop model. Let's understand. We have a machine shop with how many machines? K machines. They are operating. All the machines are operating. As soon one of the machines fails, it enters a what? A repair shop. How many repairmen do we have? One repairman. But there is a space waiting for how many, up to how many machines? K minus 1 machines. When the repairman repair the machine will go back to the what? To the working area. Did you get my point or not? The working area is not part of the queue. It's outside the queue. In other words, this is what we have. This is machine 1. All the way to what? Machine K. Where is the queue? Where is the queuing system? This is the queuing system. This is outside the queuing system. This is the what? Operating room or whatever. Clear? Then what do I have here? I have the waiting room. Yes or no? Waiting. We spell waiting. And then what? Repair. Cannot Cannot hear you. Cannot hear you. And then what? Once it repairs, it go back and what? Join the operating space. Are you following me or not? Cannot hear you. This is sometimes they also call it a what? A cyclic queue. One of the most important models in queue. Clear? Again, you might also think about this as a what? As a web server, and these are what? Multiple clients. The web server is serving what? One client at a time. One client at a time. Clear? Think about this as a what? As a sequential server. Are you following? Like a UDP type server. Remember from 450? A UDP type server. Clear? Okay, good. Now, let's set it up and we'll see if you can help me. Machines. Each machine. Did you understand the diagram? Okay. Each machine operate according to exponential operation time. Operate for a time according to exponential with parameter. Let's say alpha. Yes? Alpha. When it breaks, when a machine breaks, it enters the queue. What is the maximum size of the queue, of the waiting time, of the waiting space? It's k minus 1. Are you following me on it? Enter the queue, waiting to be what? Served. Clear so far? Cannot hear you. The service time or repair is exponential again, independent on the operation. Exponential with parameter mu. Clear? Clear? Now, after it repairs, the machine will go back and join what? Join the operating room. Clear? No response. Clear? Okay, good. Now, sketch the Markov chain and find Pn of n, Pn equal to n, where n is the number of machines in the queue system. In the queue system, which means what? The number of failed machines. The number of failed machines. Did you get, do I need to write the number of failed machines, or did you get the point? Where is the queuing system? One more time. That's the queuing system. Clear? Okay. Now, I want to ask you a question first of all. How come there is no lambda in here? Where is the lambda? Can you show it to me in the diagram? In the diagram, where is the lambda? The lambda is this one. Are you following me or not? Question. Is lambda the same as alpha? Is lambda the same as alpha? No, of course not. Alpha is the what? Alpha is the rate at which this one is what? Huh? I mean, you know, until then it will fail. But this is not the only then it will fail. You need to take the aggregate. Did you get my point or not? Okay, good. Now, let's see if you can help me. Set it up. Set it up for me. Set it up for me. How many states do I have? K states. Yes? What does the zero mean? Where are the machines? Outside. They are all what? Working. They are all working. Yes or no? Or in the case of the website, what does that mean? All the clients are what? preparing their request. Their request is what? It's not finished yet. You are writing your request. Do you understand that or not? Tell me. Still waiting? Still waiting? K alpha, very good. Y alpha alpha. This one will be one machine will go in, is the machine that will break first, which means what? It has the minimum operating time. Clear? No response. Mu. Still waiting. K minus 1 alpha mu. Help me. Help me. Mu. Did you get it? Do you feel comfortable with this? Are you getting a little bit better? Yeah. Remember, by the way, this is, I mean, think about it. This is, if you cannot do this, the rest is what? We are stuck. We cannot continue. Clear? Okay, can we write this steady? By the way, is there a possibility that the system will go unstable? Actually, the number of machines is what? It's K, it's fixed. So there is no, it's not like a machine will come from outside and get inside. Actually, the shop has only what? 7 machines. Did I say 7 machines? Sorry, K machines. Clear? 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 I don't know, they hide behind the computer so that I don't see them. Okay, can we set up the equations? K alpha times what? Agree? Agree? Okay, which means what? Did I mess up? Oh, P0, sorry, P0. Next one, K minus 1 alpha P1 equal to what? Mu P2. So what is P2? What is P2? Help me. K times what? Times what? Alpha over mu square P0. Do we agree? Do I need to continue or can you generalize it? Or do you want me to show you another one? Can you generalize it? And let's see if you can tell me. What is it? What is it? This, by the way, K minus 1. The next one will be what? K minus 2. Yes or no? So what is this? K. K times what? K minus 1. Yes? Which means what? See, what is this? Say that again? See, this one is property of N. N. So what is it? No, K minus what? No. 1 second. This is P1. P1 is what? This is K minus what? I messed up? What is this? K factorial over what? K minus N factorial. What is it? It's K times what? K minus 1 times what? K minus 2, like this one. Clear? Okay. Times what? By the way, this is not K choose N. This is what? K factorial over what? K minus N factorial. There's no N factorial in there. Clear? Okay. Alpha over what? I messed up? Mu to the what? N times what? And this is for what? Help me. 0 all the way to what? K. Clear? Okay. And of course, P0 is what? Is, help me, 1 over what? A summation N equal to 0 to K of what? K factorial over what? K minus N factorial times what? Alpha over mu to the N. Clear? And you take this and you substitute it in here. Are you following me or not? Yes or no? What does P0 means? What does P0 means? P0 means what? All the machines are outside, which means the repairman is what? Idle. What is the server utilization? No. What is the server utilization? If you tell me the server utilization is 0, means what? The server is not doing anything. It's a repairman, the machines can't break. P0 is what? The server is what? Idle. Yes? Server utilization is what? What is the probability that the server is what? Busy. Yes or no? What is it? So the server utilization is what? Clear? Clear? And what is this equal to? This is a single server case. What is it equal to? It is equal to what? Land times what? Yes. And what is this land? That's the question I need you to understand. What is this land? Clear? But first of all, I'll show it to you in the diagram and tell me. Do you understand what lambda is? Lambda is what? Is the average arrival rate into the system. Clear? Clear? Okay, good. Now, let's see if you can help me. Okay? Every machine go through a what? A cycle. Every machine goes through a what? A cycle. What does that cycle consist of? Cycle is what? Preparing or operating. Since we are talking about machine, let's talk about, if we are talking about the website, it becomes what? Preparing the request. Clear? In the machine is what? Operation, operating, plus what? Waiting. Yes? Plus what? Repair. Clear? Clear? What is the rate? What is the rate of every machine? Of only a single machine. Only a single machine. The rate, the average rate. The average rate is what? So the average rate per machine to go through a cycle. To go through a cycle. Clear? The average rate per machine is what? I'm still waiting. 1, remember the rate is what? Something per unit what? Time. Yes? So it's one machine divided. I'm still waiting. Alpha, which is the what? Average operating time? No, I messed up. What did I say? Did I say 1 over alpha? I'm sorry. Why? I'm talking about the rate. It's what? 1 over the time. Yes or no? So it's 1 over what? Alpha. Yes or no? Cannot hear you. Plus expected value of the what? Waiting time plus 1 over what? Mu. Did you get it? Yes. Did you get it? Everything is averages. Per machine. Per machine. How many machines do we have? K machine. Yes? So what is the aggregate rates of those K machines? Which is what? Which is the land. So what is the land? Land equal to what? K over what? 1 over alpha plus what? E of W plus what? 1 over what? E. By the way, what is this? Just this one. Just this one. What is it? That's E. Very good. Excellent. That's E of what? T. Did you get this or not? Which is what? Which is the average time both waiting and being what? Being served. Clear? Did you lose me? Where did the K come from? Did you answer where the K come from? Every one of these machines goes through a cycle. The cycle is what? Operation, waiting, repair. Then what? It repeats. Yes or no? Repeats. Operation, waiting, repair. Operation, waiting, repair. Yes? That's this one. 1 over. This is the average operation time This is the what? Average waiting time. This is the what? Average repair time. Yes? How many machines do we have? K machines. Yes? So it becomes what? It becomes this. Now from here, what is the unknown in this equation? Let me see if you can tell me what is the unknown in this equation. What is the unknown in this equation? Hey, equation, the unknown is what? Is, do you agree? Why is it E of W? The lambda, I'm going to get it from here. Yes or no? P0 depends on what? What does P0 depend on? K, alpha, and what? Mu. All of these parameters will be given in the problem. You agree? No response. Yes or no? I will get P0. From P0, E of S is what? Is 1 over mu. Yes? I will get what? I will get lambda. And from lambda, I will get what? The E of W. By the way, once you get E of W, what can you get also? Using Little's theorem. You can get what? E of NW. You can get all the others. Are you following me on that? Clear? Clear? Okay. Let's see if you, I have 10 more minutes to go. Let me squeeze another model. Did you get this one? Did you get this one? This one, again, as I told you, is most widely. Do you understand why they call it cyclic Q? Cyclic Q because what? Because the arrivals are not coming from what? Outside of the plant, of the population. The population is just what? K. Clear? Okay. How about this one? What number? What number? 7. How about this one? M, C, K, K. What is this? Arrival is what? Poisson. Service is what? Poisson. Oops. Service is exponential. C, repairman. Question. Could the number of repairmen be more than the number of machines? Huh? It's unnecessary. You have 5 machines. You are going to hire 7 repairmen. Why? By the way, I'm assuming every repairman know what they are doing. It's not like they don't know what they are doing. Do you understand that or not? You have 5 machines. Are you going to hire 7 repairmen?
The time
Why?
is 22 o'clock.
Clear? Okay. And what is the KK? K is the what? The size. And the K is what? The population. So now what do I have? Let's see if you can help me. This is what? Machine 1, 2, all the way to what? K. And then what? There's the Q. Yes? And then what? What are these? 1, 2, 3. Sorry, C. Yes? How many space for the waiting? The waiting. How many can there be there? Here, waiting. K minus C. Why? Because the total is what? K. By the way, if there is K minus C in here, it means what? None of the machines are what? Working. Clear? Okay. Then what? Clear? Clear? Can you set up can you set up, where is the lambda, by the way? Where is the lambda? It's the lambda. Clear? Question, by the way. Does lambda have anything to do with the server? In other words, will the lambda be the same equation as before? As an equation, not as a value, but as an equation, will it be the same? It will be the same. It will be what? K over what? 1 over alpha E of W plus 1 over mu. Yes or no? Yes. Oh, but can you set up the Markov chain for me? And then I promise I will let you go. You want to start your party, I know that. And the weekend you go to parties, I know that. I wonder why don't you invite me? I can be fun, by the way. If I try, I can be fun. How many states? How many states? K. It's 0 to K. Question. Do I need to break it into 2 regions or 1 region? Let's start. Let's start before we run out of time. 0, 1. What do I write here? No. C minus 1. C plus 1. K minus 1. K. Did you get it? No response. Yes or no? Let's help me. Help me. K alpha. Yes? Help me. You. Help me. K. Help me. 2 mu. Help me. No. K minus C plus 1. Are you losing me? This one? K minus C mu. Finally, alpha C mu. Not K mu, C mu. We only have C servers. Clear? No response. Clear? Okay. Can we, can I write one equation, or do I need to separate it into equation? I need to separate it into equation. This is all CMU, just like we did in the case of what? MMC. Clear? Just like we did in the case of MMC. I will let you do this at home. But did you get it? Did you get it? How do you feel? Tell me how you feel. Don't get emotional. Huh? Tattooed? Especially I'm talking to those who took the 503 with Professor Ozabo or Kaire or whatever. How many of you took it with Professor Ozabo? Kaire? And was there a third one? Who was it? Oh, Professor Costco. How do you feel? Did he discuss this? How do you feel? By the way, I posted tutorial, a chapter from Stallings' book on queuing. How many of you read it? By the way, you are looking at me as if I'm talking in a different language. We will get better. We will get better. I promise you. We will get better. But queuing is not easy. Nobody told you it's easy. Did somebody tell you it's easy? Nobody told you it's easy. But did you get the idea? You have a nice weekend. By the way, in this week, once I get home, after I eat, of course, I will be splitting the class into 2 groups, and I will be assigning each TA, designate each TA to a single group. Remember always, you can see any TA during their office hours. However, you need to email only your what? Designated TA, and of course, CC it to me.
This concludes EE 555 Review Session Part 2 for Friday, January 24, 2014.